So let us revisit loops. So we saw that we have two types of loops in Python. The first is a for loop where the value ranges over a list in general, or say the output of a range sequence. So for I in L, we'll repeat the body for each item in the list L. Sometimes we don't know how many times we need to repeat in advance. So then we use the while form. So the while takes a condition and it keeps repeating the body until the condition becomes false. But the main thing to notice in both these cases is that how long the loop takes is determined in advance. Either we have a fixed number of iterations depending on the number of values in L for a for loop, or we keep going until the condition becomes false. We cannot stop before that. Now it does turn out that sometimes we have natural situations where we want to cut short the loop and not proceed till the very end. Suppose we want to write a function find pos, which finds the first position of a value v in a list L. So we had seen that there is a built-in function called index which pretty much does this. So L.indexv will report the first position where v occurs in the list L. However, the index function will report an error if there is no occurrence of v in L. So we want to change that slightly. And what we want to say is that if there is no v in L, report minus 1. So either we get a value between 0 to n minus 1 where n is the length of the list, or we get the value minus 1 saying that v is not in the list. So here is a while loop implementation. We use a name found, as the name suggests, to indicate whether the value has been found or not. Has v been seen so far? Initially we have not seen any values in L, so the found is false. And we use I as a name to go through the positions. So I is initially 0 and we will increment I until we hit the length of L. So long as while I is less than the length of L, if we see the value we are looking for, then we update found to be true and we mark the position that we have found it to be pos. At the end of this, if we have not found the value, so the value found has not been set to true, that means there was no v in the list, then we will set pos to minus 1, which is the default value we indicated at the beginning. And then we return the current value of pos, which is either the value of pos we found or the value is set to minus 1 because we didn't find it. So there are two points to observe about this. The first point, which is the main issue at hand, is that we are going to necessarily go through every position I from 0 to the length of L minus 1, regardless of where we find it. So supposing we had several hundreds or thousands of elements in our list and we found the value at the very second position, we are still going to scan the remaining hundreds of thousands of positions before we return the position 2. Now this seems very unnecessary. The other point, which is an issue of correctness, so this is an issue of efficiency, that we are running this loop too many times unnecessarily in case we are actually able to report the first value quite early. The other problem, which is correctness, is that we want to report the first position, but the way we have written it, every time we continue past the first position and we find another copy of v, we are updating the position to be the new thing. Right? So we are actually finding not the first position but the last position. So this is not a very good way to do this. Right? So we first change that. So we say that we want the first position. So if we want the first position, we want this update to happen only if we have not found the value so far. So we add this extra condition which says that if Li is v and we have not found it so far, then we update found to true and we set pos to I. So this ensures that pos is updated to I only the very first time we see v. After that, the value found prevents us from doing this update again. So at least we are correctly finding the first value of the position. And finally, as before, if we never find it, then the value found is never set to true, and so we report minus 1. So now the issue is, why do we have to wastefully go through the entire list, even though after we find the very first position of v in L, we can safely return and report that position. So a more natural strategy suggests the following. We scan the list and we stop the scan as soon as we find the value. So wherever we find the value for the first time, we report that position and we get out. Of course, the scan may not find the value. So if the scan completes without succeeding, then we will report minus 1. So we could think of doing this using a for loop. Okay? So we go through every value in L using a variable x. So x is a name which goes through the first element, second element. These are not positions now. These are the actual values. So we check whether the value x that we currently pick up from the list is indeed the value v we are looking for. If so, we exit and we report the position of this x. If we come to the end of the loop and we have not seen x so far like before, we want to report -1. So here is a first attempt at doing it. So let's go through it systematically. So first of all, we have this loop. Right? So for each x in the list, if x is v, then we report the position. Now we have to find the position because we are going through the values. So this has forced us to use a name I to record the position, and we have to manually do this. So like in the while loop, we start with the position 0, and in every iteration we increment the position. Okay, so this is only the first version of this. We will see how to fix this. So we have to separately keep track while we are doing this for, separately keep track of the positions and report it. But what is new, and this is the main issue to be highlighted here, is this statement called break. So what break does is it exits the loop. So this is precisely what we wanted to do. If x is v, we have found the first position, we don't want to continue, we just want to break. If not, we will go increment the position and go back. Now, how do we record at the end? We don't have this found variable anymore. How do we know at the end whether or not we actually saw it? Okay, so the question is, was pos set to I or was it not set to I? Well, the default value is -1. So supposing pos is not reset, we want to report -1. So this is why in our function, we have actually initially set pos to be -1. So the default value is that we don't expect to find it. So it's like saying found is false. So by default, the position is -1. At the end of this loop, if we have not found it, pos has not been reset, so it remains -1. On the other hand, if we have found it without looking at all the remaining elements, we have set it to the first position we found it, and we have taken a break statement to get out of the loop, so we don't unnecessarily scan. So when we come here, either way, we have either reported the first position we have found it, or in the worst case, we have scanned through the entire list and we have not found it, in which case the initial value -1 is there. So in any case, we can return pos and we have no problem. So this is just to illustrate the use of the word break, okay, which allows us in certain situations to get out. Now remember, in the worst case, we don't find x in it. So the worst case behavior of this loop is no different from the situation without the break. We have to go through the entire list and we have to come out only when we have scanned everything. But if we do find it, we can avoid some unnecessary computations. So we can simplify this a little bit by first removing this I. Instead of scanning x, actually it is better to scan the positions. So it's better to say pos is -1, but instead of going through x in L, it's better to go through I in the range 0. Remember now this is implicitly 0 to the length of L -1. So we go for I in the range 0 to length of L. So if we don't give a 0, if we give only one argument, this is taken as the upper bound. So this will go through all the positions. And instead of checking x, we check L at position I. So if L at position I is V, then we set the position to this current value and we break. So by changing the variable that we put in the for, we have got a slightly more natural function. And again, we have this clever trick, okay, which says that since we set pos initially to -1, if we did not reset it here, if no value in the range 0 to n-1 produced a list value which is equal to the value we're looking for, we will return -1 as before. Okay, so this requires this clever trick. So the question is, what if we don't have a situation where such a clever trick is possible, or if we don't think of this clever trick, how would we know at this point? Okay, so remember now there are two situations. Either we break, okay, so if we break, that means that the value is found. Okay, or if we don't break, if we terminate normally, right? If the loop ends by going through all the things, then V is not found. Remember, even if V is found at the very last position, we will first break. We will not go back and say that the loop ended. So if we see V at any position from beginning to end, we will execute the break statement. If not, we will not. So the question is, can we detect whether or not we broke out of this loop or whether we terminated separately? So Python is one of the few languages which actually provides a way to do this. So it allows something that looks a bit odd because of the name. It allows something called else, which we saw with if. It allows an else for a loop as well. The idea is that the else, this part will be executed if there is no break, if the loop terminated normally. So don't worry about the fact that else doesn't mean this in English. Okay, so it's just a way of economizing on the number of new words you need to use. So if you see an else attached to a for, it could also be attached to a while. It means that the while or the for terminated in the natural way. Either the for iterated through every value that it was supposed to iterate through, or the while condition became false. Okay? If it was, on the other hand, aborted by a break statement, then the else will not be executed. So here, for instance, now we don't initialize, okay, so we no longer have this clever trick, okay, we don't have this anymore. So what we say is that for I in this range, we check, and if it is there, we set the position to be the current I, and then we break. Now, if we have actually gone through this entire list and not found it, pause is undefined. So if pause is undefined, we need to define it before we return the value. So we have this else statement. So now we say, okay, we have come through this whole thing and there will be no break. So there is no V in L, because otherwise we would have done a break, and otherwise pause will be set to a valid value in the range 0 to n minus 1. So there has been no break, there is no V in L. So let us set pause to -1 and then return. Okay. So to summarize, it is very often useful to be able to break out of a loop prematurely. We can do this for both for and while. We can execute the break statement and get out of a loop before its natural termination. And sometimes it is important to know why we terminated it. We terminate because the loop ended naturally or because we used a break statement. And this can be done by supplying the optional else. So both for and while also allow an else at the end. And the statement within else is executed only when the loop terminates normally.